The definition of a parallelogram is that opposite sides are parallel. So another special property about parallelograms are that opposite sides are congruent. So if this is a parallelogram and this is 6 and this is 6, then we know that this has to be 8 and this has to be 8. So not only are they parallel with these markings, but they're also congruent. So as soon as we know that we have opposite sides congruent, then we know it's a parallelogram. So why is that true? Well, if you had a parallelogram, these two sides are parallel, you can draw a transversal, and you're going to have alternate interior angles. Oops, I did two markings, but I did different colors. Because of these two angles are parallel, these two sides are parallel, and the black sides are parallel. Then that would be these two triangles are congruent by angle side angle because of this property being reflexive, these two sides being reflexive. So if those two triangles are congruent, then their corresponding parts have to be congruent. That's why the two opposite sides are congruent, and these two are congruent. So a parallelogram is a quadrilateral with opposite sides parallel. Opposite sides of a parallelogram are congruent. Another property is opposite angles of a parallelogram have to be congruent. So just like we drew the triangles above, we know that these two angles correspond. So therefore these two angles, which are called opposite angles, are congruent. And these two angles correspond. Those are opposite and they're congruent. So if I'm looking at this one right here, if I know that this has to be 85 over here because they're opposite. I also know that because these two lines are parallel, this is my transversal, this has to be 95 degrees because these two angles add up to 180. And this one's opposite. And these two angles add up to 180. And you can do it algebraically too. So in this second example, because we know that opposite sides are congruent in a parallelogram, we set these two equal and get y equals 3. And then you set these two blue ones equal, 135 minus x equals x plus 15, and we get that x equals 60. So we have what's called consecutive angles. These two are consecutive, these two are consecutive, these two are consecutive, these two are consecutive, and we have opposite angles. These two angles are opposite, and these two angles are opposite. Consecutive angles add up to 180, and then opposite angles are congruent in a parallelogram. Another property they have is that diagonals of a parallelogram bisect each other. So bisecting each other means that they cut each other in half. Okay, so these two segments are congruent and these two segments are congruent. And that all goes back to congruent triangles as well. So what you have to be careful of is these two sides are congruent and these two, but it doesn't mean that these two are congruent or these two are congruent. So as soon as we know that the diagonals bisect each other, then we know that it's a parallelogram. This one would not be a parallelogram because this is 5 and this is 6. This would have to be 6 and 6, and this would have to be 5 and 5. So that is not a parallelogram. And then down here you can use these algebraically. These are all algebraic examples. So we know that 2x has to equal 10 because the diagonals bisect each other. We know that y plus 5 has to equal 20 because the diagonals bisect each other. Same with down here. Let's look at this example. So I know that 4x minus 2 equals 3y minus 1. I know that 3y minus 3 equals 3x. In this case, you're going to have, you're going to be solving a system of equations. So what we did right here is, in order to solve a system, you have to get one way to do it by substitution is you have to get one of the variables by itself. So in this case, you divide 3 from both sides. So 3y divided by 3 is y. Negative 3 divided by 3 is 1. Negative 1. So x equals y minus 1. So in this second equation, instead of writing x, right here, we write y minus 1. So it is 4 x, which is y minus 1, minus 2 equals 3y minus 1. And so you solve for y in this problem and get y equals 5. In order to get x, you plug it back in. So this goes back to algebra with solving systems of equations. Same thing with this problem right here. So in this problem, you set these two equal and these two equal, which we did right here. In one of these, you're going to solve for x or y. I would solve for x in this equation, so divide both sides by 4 and get x equals y plus 1, and then plug it in right here. So this was 3y minus 20 equals 2. But instead of writing x, you put in parentheses y plus 1. Solve for y is 28, plug it back in, you get 29. And the last one is another system of equations. X is 5, y is 3.